This week, learn how to speed up row-wise operations on your Pandas data frames. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I want to look at Pandas and a topic that has come up a few times recently, which is how do I apply a function to all the rows in my data frame when it's not something that can just take series natively. And oftentimes, folks will resort to using loops. Anytime you're writing a loop in Python, you should think very carefully about if there's another way to do it, because traditionally loops are one of the slower functions that you can do. So let's go ahead and import pandas as PD. And I'm going to look at hail reports. So we recently had quite a bit of hail fall. So we're going to go to sbc.noaa.gov/climo/reports/ then the year, month, day, rpts, hail.csv. And we need that to be a PD for pandas. Now, if we look at the head of this data frame, make sure everything read incorrectly, we see we've got time, size, location, county, state, lat, lon, and then some comments. Now, we might want to do some classification on this. What I'm interested in is assigning a standard name, so quarter, nickel, golf ball, that sort of thing, to the hail sizes. Sometimes they're in the comments, sometimes they're not, but if I want to make a quick histogram of those groupings, I need to have them categorized. You could do this several ways. The first that comes to mind is a function that we give the size to, and then it's going to return us a string with the standard name for that size or that size range. Now you could do this a few ways. One way, using the if, elif, else structure, wouldn't require two conditional checks in every elif, but I think that's a little less clear, especially to folks that don't have as much flow control experience. And the number one goal of your code should always be readability. So we're going to make a function with def, make NWS hail size, and it's going to take a size argument. First thing in every function we write is triple bad quotes and a doc string. Convert hail size in inches to NWS standard names. And now what we need to do is make our if, elif, else blocks. So if the size is greater than or equal to 0.5 and the size is less than 0.75, I'm going to return marble. All right, if size is greater than or equal to 0.75 and size is less than 0.88, I'm going to call it a penny. And we're going to use these as elifs. Now I'll go ahead and speed up the typing. When you get to the end of this, you can pause it and catch up at your own pace. All right, so now we've got all of our size ranges coded up, 3/4 to 0.88, penny, nickel, quarter, half dollar, walnut, golf ball, hen egg, tennis ball, teacup, softball, grapefruit. And if it doesn't fall in any of those categories, we're going to return none because we don't know what it is. All right, let's give it a test. Let's go with a 1.0. And that should be quarter. and that's what we get back. So we think our function works. Now let's try to apply it to our data frame. Make NWS hail size. Our data frame is called hail reports. We want to use the size data series or column and divide it by 100 because that gives us inches. And that doesn't work. And this is because we're comparing the truth value of a series. So what it's trying to do is take that entire data series and run it through as size. So what we want to do is to iterate over every row. And it's just one example of times where you'd want to iterate over each row in a data frame, pass that row to a function, have operations done, and then put it back in the data frame as a result. So let's look at one way to do it, and this is how I've done it for a long time. And I'm going to use timeIt. So our sizes are going to be an empty list for row in hail reports dot iterRows, which just goes over each row one at a time. Sizes dot append. Make NWS hail size, row, that's a tuple that has the index and then the content. So the index is 0, the content is the one thing in that tuple. And then we want the size. And we're going to divide that by 100 to get in inches. Remember, timeIt's going to run this function several times and give us an average time it takes to do this. So 13.6 milliseconds. That's quite a while for not that many reports, really. If we look at our hail reports, tail, yeah, we're only looking at 178 reports. 13.6 milliseconds may not be much now, but what if you wanted to do a 6 or a 10-year climatology? It could get pretty slow. So now let's take our function. I'm going to copy and paste it. And we're going to do a couple of small modifications. Instead of making it take a size, we're going to make it take a row from our Pandas data frame. And then we're going to define size, just so we don't have to do a lot of recoding here, as getting the size from the row and dividing it by 100 to get back to inches. I'm going to use timeIt again. And now I can directly put this, I don't have to make an empty list or anything like that. I'm going to create a column called common size, hail reports dot apply, and then we give it our function. And since we want to go row-wise, we're going to use axis equals 1. So it's going to take each row of the data frame, put it into make NWS hail size, and then put all the results from those calls into a new data series in our data frame called common size. The exact same task, but it took 2.1 milliseconds. That's a factor of 6 speed up. And if we look at our data series, our data frame now, there are our common sizes. In fact, if we wanted to get just a really quick visualization, not something that's publish worthy for sure, import matplotlib.pyplot as plt, matplotlib inline, hail reports, we're going to use the common size .hist. And there we go. So we have almost a linear distribution of hail reports from May 3rd, 2021. I hope that you found this useful and it will speed up your Pandas operations. And I'll see you on next week's MetPy Monday.